Hello all, today we're going to be talking about completing the square and vertex form. So let's review a little bit about perfect square trinomials to see what kind of pattern exists in these types of trinomials. So if we take a look at b, which is 4, if I divide it by 2, I'm going to get a positive 2. And then if I take this positive 2 and square it, I wind up at 4. So this pattern is going to exist within each perfect square trinomial. So if we look at the second example, if I take b, which is negative 8, divide it by 2, I get negative 4, and then take negative 4 and square it, I arrive back at 16. So this kind of helps us with a shortcut of how to factor. Since we know that two numbers that multiply to 4 are 2 and 2, and they both add to 4, we wind up with something like x plus 2 times x plus 2, which can be simplified to x plus 2 squared. So you'll notice this number that I got when I divided by 2 wound up being the number in the parentheses squared. So our shortcut is when I divide it by 2, I'm going to get negative 4, and that's going to be the number in the parentheses when I square it. So that happens for all of these, right? 16 divided by 2 is positive 8. If I square positive 8, you wind up getting 64, which is the number I have already. So I can, in fact, factor it this way. And finally, our last example, divide by 2 to get negative 5. Negative 5 squared is 25. That's the number that was added here. So I can factor to make it x minus 5 squared. All right. So what does completing the square actually look like? Well, if I have this trinomial as such, you'll notice that if I divide this by 2, I get 2, and squared it's 4. That's not the number that's here. So what we're trying to do is actually force this factoring to happen, and then we're going to have a number at the end being added or subtracted, which we don't care because we really just want to see this format. So when we want to complete the square, we have to do a setup to start with. So give yourself a little bit of room, and it's going to be y equals x squared plus 4x plus a number. Now put your negative 10 here, minus a number. Because if I add and subtract the same number, it's like I didn't do anything, because these two will make a 0 together. So it's like I didn't change anything, which is the point. I don't want to change anything. I just want to make it look a little bit different. So now we're going to take b. So this positive 4, I'm going to do it off to the side here. Divide by 2 to get a positive 2. Take that positive 2 and square it to get a positive 4. So we've got two numbers here, and they each play an important role in completing the square. So since I've got my setup, this number that I squared and got 4, that's what's going to become my plus and minus. Now I can take my first 3, and you'll notice this first 3 looks exactly like the one we have up here. So I can rewrite it in its factored form. Now the shortcut is the same one we can use before. When we divided by 2, this is what's going to go into our parentheses. So this becomes x plus 2 squared, right? I used this guy. I already used the plus 4 and minus 4. And now my last step is to simply add or subtract whatever these last two numbers are. So I'm going to get negative 14. And this is now what's called vertex form. So let's take a look at the next example, right? So now I'm going to have x squared plus 10x minus 5. Okay, we want to do this vertex form again, in which case I'm going to get a number at the end. I don't really care what it is. The point is that my first 3 become this factored form. So I can take this positive 10 off to the side, divide by 2 to get positive 5, take positive 5 and square it to get a positive 25. This is the number that I'm going to be adding and then subtracting. This is the number that's going to go into the parentheses. So let's set up our formula. X squared plus 10x plus a number minus the 5 minus a number. Now I fill in the blanks. So this goes here, and this one I'm going to use in a minute. So my first 3 can now be placed in factored form. So x plus 5 squared. And my last 2 numbers need to get added or subtracted, so that makes negative 30, and you're finished. So my last question is going to have a b of negative 12. So I'm going to take negative 12, divide by 2 to get negative 6. Signs are important. Negative 6 is squared, makes 36. Once again, negative 6 is what's going to go in the parentheses in my last step. And 36 is what's going to go now in that plus and minus space that I provide. So y equals x squared minus 12x plus a number. Put that 15 down, minus a number. Here we go. 36 goes in the spaces I left available. Factor the first 3. Right here is the x minus 6. And then the last 2 are going to make minus 21. All right, so now we can continue. So why do we even want to write our trinomial into this format? Well, it's because this format is actually called the vertex form of a quadratic equation, right? So this is the basic version. There's a little bit more complicated ones, but this is all we really need to know for right this second. But do you notice this format, x minus a number squared plus k? This helps us identify the vertex. And in case you forgot, the vertex is the turning point, and the axis of symmetry is the line that goes through the vertex that creates a symmetrical parabola, right? So this h and k is just your x and y value. This is just a formula to use as a guide. But you'll notice that h, right, changes sign when I pull it out to make a vertex. So this was minus h in the parentheses, but in our vertex as a point, it's a positive h. And then we've got k, which was a positive k, and it still is. So these will keep the same sign, whereas the h is going to reverse the sign. Okay, and our axis of symmetry is always going to be x equals, and then I'm just going to plop down the h that I already have. All right, so let's take a look at one of our examples. Okay, so I already did completing the square. I arrived at this answer. We can identify the vertex and axis of symmetry now. So our vertex is going to come from this 3 and this negative 5. So when I write this out, my vertex is, well, instead of positive 3, my x value is going to switch signs. So this is going to be negative 3. My y value is going to keep the same sign. So again, my x value switches signs, but my y value stays the same. My axis of symmetry is x equals and whatever the vertex is for the x value. Done. So if I look at my next example, once again, my x value comes from this 10. My y value will be this 4. This is going to tell me where I'm turning. This gives me this point right here. Okay, so my vertex is negative 10, comma, 4. And my axis of symmetry is x equals negative 10. My last example, my vertex once again has to change signs for the x. So instead of negative 4, it's a positive 4. And my 2 will stay the same. My axis of symmetry, x equals 4. That's all. Hope you enjoyed. Thanks for watching. Bye.